3 earthquakes, 3 tsunami warnings, 67 days. April 20th, Japan. A magnitude 7.7 strikes off the Sanriku coast. The same coast, the same fault, the same geography that produced the 2011 Tohoku earthquake and killed over 18,000 people. Tsunami sirens activate across Aomori, Iwate, and Hokkaido. 82,811 households are ordered to evacuate. Japan issues a large-scale earthquake caution advisory, only the second time in history this specific warning has ever been used. And the Japan Meteorological Agency announces that the probability of a magnitude 8.0 or larger megaquake has increased tenfold. June 8th, the Philippines. A magnitude 7.8 strikes the southern coast of Mindanao, the strongest earthquake to hit the Philippines since 1976. Tsunami warnings are issued across the southern Philippines, Indonesia, Malaysia, and 6 Pacific Island nations. 81 people are killed. Over 1,300 are injured. 6 million people feel the shaking.
June 24th, Venezuela.
A magnitude 7.2 and a magnitude 7.5 strike 39 seconds apart. Tsunami advisories activate for Puerto Rico, the U.S. Virgin Islands, and the entire northern Caribbean coast. 1,430 people are dead. 68,900 are missing. 58,870 buildings are damaged or destroyed. 3 earthquakes, 3 different tectonic systems, 3 separate ocean basins placed on tsunami alert, and all of it happened in the space of 67 days. The question is not whether this is unusual. It is. The question is what it means and what it is pointing to. To answer that, you need to understand what the Ring of Fire actually is, not as a name, not as a metaphor, but as a physical structure. The Ring of Fire is a 40,000-kilometer horseshoe-shaped chain of tectonic plate boundaries that encircles the Pacific Ocean. It passes through New Zealand, Papua New Guinea, the Philippines, Japan, the Aleutian Islands of Alaska, the Pacific coast of North America, Central America, and South America. Along this boundary, the Pacific Plate and several smaller plates are being driven beneath the surrounding continental and oceanic plates in a process called subduction. As those plates descend, they generate the deepest earthquakes on Earth, the most explosive volcanic eruptions, and the majority of the world's tsunamis. Roughly 90% of all earthquakes on this planet occur along the Ring of Fire. 81% of the world's largest earthquakes happen here. The 3 events of 2026, Japan, the Philippines, Venezuela, do not all sit on the Ring of Fire itself. Venezuela is a strike-slip boundary on the Caribbean Plate's eastern edge, not a subduction zone, but it is connected to the same global tectonic system. When stress moves, it does not respect borders between plate boundaries. It propagates through the crust, transfers across fault systems, and loads distant structures. And in 2026, 3 of those structures have moved, within 67 days of each other. Japan's April 20th earthquake struck the Sanriku-Oki subduction zone, where the Pacific Plate dives beneath the Okhotsk microplate at a rate of 7.9 to 9.2 centimeters per year. This is the exact convergence zone that ruptured on March 11, 2011, producing a magnitude 9.0 earthquake and a tsunami that reached heights of 40 meters in some locations. The April 2026 event was far smaller, roughly 200 times less energy than the 2011 main shock, but its location and fault mechanism were identical. It was a thrust fault rupture on the Japan Trench, the same structure, the same geometry. And the JMA's advisory about an elevated megaquake probability was not precautionary language. It was based on specific seismological data. A 7.7 event on a subduction zone of this scale has historically preceded larger ruptures in the same system. The 2011 earthquake itself was preceded by a magnitude 7.34 shock just 2 days before the main shock. The April 2026 advisory expired after 7 days without a follow-on event. But the fault is still there, and it is still loaded. The Philippines earthquake of June 8 struck a different but related system. Mindanao sits at the collision point of 2 major tectonic convergences, the Cotabato Trench to the west, where the Sunda Plate subducts, and the Sangihe Trench to the south. The 2026 rupture occurred near the junction of these 2 systems, at a depth of approximately 10 kilometers, shallow enough to produce both violent shaking and significant tsunami potential. The Cotabato Trench is the same fault that produced a magnitude 8.0 earthquake in 1976, killing 8,000 people. The 2026 event, at magnitude 7.8, released more than half the energy of that event at a similar location. Aftershocks have continued daily since June 8th. The fault has not returned to background levels of activity. Venezuela's doublet on June 24th sits outside the Ring of Fire, but its seismic energy has not stayed local. Surface waves from a magnitude 7.5 strike-slip earthquake travel around the circumference of the Earth multiple times before losing their energy. The Japan Trench felt them. The Cotabato Trench felt them. The San Andreas Fault in California felt them. Whether that energy was sufficient to trigger activity on already loaded systems is a question seismologists cannot answer with certainty. What they can say is that faults sitting near their critical stress threshold require only small perturbations to rupture, and perturbations from a Venezuelan doublet are not small. Here is the picture the data draws. In the first 180 days of 2026, the planet has produced 3 separate M7.5 or larger earthquakes, each triggering regional tsunami warnings, each striking a tectonic system that had not fully discharged in recent history. Japan's Sanriku zone has been accumulating stress since 2011. The Philippines' Cotabato Trench last fully ruptured in 1976. Venezuela's Bocono El Pilar system had not produced a comparable event since 1812. All three moved within 67 days of each other. Stop. Let that timeline sit for a moment. Not in decades, not in years. 67 days.
Seismologists are careful with pattern recognition.
The Earth produces large earthquakes continuously. In any given year, the planet generates roughly 17 major earthquakes of magnitude 7.0 or above. 3 in 67 days is above average, but not statistically impossible as an isolated cluster. The scientific concern is not the cluster itself, it is what each of these events revealed about the systems surrounding them. Japan's April earthquake confirmed that the Sanriku-Oki zone is still capable of producing a large thrust rupture, and that the broader Japan Trench, which has sections that did not fully rupture in 2011, remains critically loaded. The Philippines event has produced over 1,000 aftershocks, suggesting the Cotabato and Sangihe systems are in a period of elevated instability. And Venezuela's doublet has transferred stress to the Caribbean, Colombian, and North American plate boundaries. The faults that scientists are now monitoring most closely fall into 4 categories. The first is the southern Japan Trench, specifically the Nankai Trough, which runs along Japan's Pacific coast from the Kii Peninsula to the coast of Shikoku and Kyushu. The Nankai Trough has a recurrence interval of 100 to 150 years for large subduction earthquakes. The last major Nankai event was in 1946. That is 80 years ago. Japanese government models estimate that a Nankai Trough megaquake would kill between 32,000 and 323,000 people, depending on the time of day. The probability of a magnitude 8 to 9 event in the next 30 years is estimated at 70 to 80%. The second is the Cascadia subduction zone, off the coasts of Oregon, Washington, and British Columbia. Cascadia last fully ruptured in January 1700, 326 years ago. Its recurrence interval is estimated between 200 and 500 years. The subduction rate is 4 centimeters per year, and the energy stored in 326 years of unreleased strain is not theoretical, it is measurable. GPS sensors show the coastline of the Pacific Northwest compressing landward at rates consistent with a fully locked subduction zone building toward a megathrust event. FEMA estimates a full Cascadia rupture would kill 13,000 people and displace 1 million. The third is the Alpine Fault in New Zealand, which last fully ruptured in 1717, 309 years ago. Its recurrence interval is approximately 300 years. It is, by that measure, overdue. The Alpine Fault runs 600 kilometers along New Zealand's South Island. A magnitude 8 rupture on this fault would be felt across the entire country and would generate a tsunami affecting the South Pacific. The fourth is Colombia. The same Science Media Center experts who analyzed Venezuela's doublet noted that Bogotá, Lima, and Quito all sit on building stock comparable to Caracas. The Caribbean plate boundary that ruptured in Venezuela runs directly into the Colombian Andes, and Colombia has not seen a major rupture on its primary fault systems since the 1999 Armenia earthquake, a magnitude 6.1 that killed 1,900 people in a much smaller event than what the fault is capable of producing. 3 earthquakes in 67 days did not cause these fault systems to become dangerous. They were already dangerous. What the 3 events of 2026 have done is remind every seismologist, every emergency planner, and every resident living near a subduction zone of something the data has been saying for years. The planet is not in a quiet period. The ring of fire is not resting, and the faults that have been silent longest are the ones carrying the most weight. The question scientists cannot answer is when. The question they can answer, and have answered, repeatedly, in peer-reviewed studies and government hazard models, is whether. And the answer to whether has never been in doubt. Subscribe to Seismic Alert. We will be watching when the next one moves.